okay, sorry about that. You will get 36.4 degrees for the last problem there. All right. Number 7. Ms. DeMassa is flying a kite with a 300-foot string. The kite makes a 43-degree angle with the ground. Ms. DeMassa is standing on a rock that is 3.4 feet above the ground. How high vertically is the kite? So anytime you have a word problem, my suggestion is always going to be to draw yourself a picture. So Ms. DeMassa is down here on the ground. She's flying her kite like this. We know it's going to give me a right triangle because that's all we've been working with, right? The string is 300 feet. So if here's the kite, here's where I'm holding it. This is the 300. The kite makes a 43-degree angle with the ground. So that means here's the ground. This is 43 degrees. She's standing on a rock that is 3.4 feet above the ground. So here's the rock. So this extra space here is 3.4. I want to know how high vertically is the kite. So I want to know x right over here. Okay. Now, I know I'm going to be using the x and using the 300. The x is my opposite. The 300 is my hypotenuse. So if I'm trying to find which one uses the opposite and hypotenuse, that would be the sine. So my equation looks like this. I've got sine of the angle, 43 degrees, equals opposite over hypotenuse, x over 300. I'm just going to solve it now for x. So I'm going to get rid of that 300 by multiplying both sides. Okay, so I've got 300 times the sine of 43 is equal to my x. I'm just going to put that into my calculator now. 300 times the sine of 43. Okay, I get 204.5995. Then that's not my final answer, right? This height right here is just 204.5 feet, right? But then I'm also standing on a rock that's another 3.4 feet above the ground. So I have to take that 204.5995 and I have to add 3.4 to that number because I'm an additional 3.4 feet off the ground. So when I do that, if I round to the nearest tenth, my final answer is I'm at 207.99, so we can round that to be 208 feet high. And there's your height. Okay. Now for the next section here, we're going to convert each degree measure to radians and each radian measure 2 degrees. All right. So if you are putting them from degrees to radians, you're going to multiply whatever this is times pi over 180. Okay? We go straight across. We get 130 pi over 180. And then I just reduce my fraction here. So I can divide both of these by 10. I end up getting 13 pi over 18 as my radian measure. Same thing over here. I'm going to multiply this times pi over 180. So I get negative 285 pi over 180. And then I just reduce these numbers. I can divide them both by 15. And if I divide them both by 15, I get negative 19 pi over 12. So there you go. You just converted those degrees into radians. Now we're going to go the opposite way. I'm going to take our radians, turn them into degrees. So in order to do that, I'm just going to rewrite this one. I'm going to multiply just by the opposite. So I'm going to, or by the reciprocal. So I'm going to multiply by 180 over pi. And when I do that, I'm going to notice pi divided by pi, these are going to cancel. And then I'm just stuck with just some regular old numbers that I'm going to multiply. So if I do negative 17 times 180, I get negative 3060. If I divide that by 9, I get negative 340 degrees. Same thing over here. 7 pi over 36, I multiply it by 180 over pi. My pi's cancel. I get 1,260 divided by 36, which is 35 degrees. And now I've converted from radians to degrees and degrees to radians. Okay. For number 12 and 13, we're going to give two coterminal angles, one positive and one negative, and we're going to give the reference angle. So we're going to make sure we draw a picture for each one, and then we're going to give two angles that end in the same place, right? Coterminal means they end in the same spot on the unit circle. Reference angle is the acute angle that gets you back to the x-axis. So we're going to draw a picture for each one of these here. So the first one I'm given is 290 degrees. So I'm going to start with my x and my y, and I'm going to mark my degree measures. So I know this is 0 and 360. This is 90, 180, and 270. Okay. If it's 290 degrees, that means my initial side's over here on the x-axis. My terminal side has to end at 290 degrees. So that means, remember, we're going, since it's a positive, we're going to go counterclockwise. So I go all the way around to 270, and then I add another 20 degrees. So it would be somewhere over here. So this whole thing is 290 degrees. Okay. To get my coterminal angles, essentially all I'm going to do is this. I'm going to take this number, 290, I'm going to add a full revolution to it, so I'm going to add 360 to it, and then I'm going to take away 360 from it. That will give me two angles that end in the same place. So if I take 360 and I add it to 290 degrees, I'm going to end up getting 650 degrees. That would be a positive angle that ends in the same place. A negative angle that ends in the same place means you'd have to start here and end down here. You'd have to go the opposite way. Is if I take 360 and I subtract 290 from it. I get 70 degrees. But remember that this 70 degrees has to be negative because I'm going the opposite way. So it would be a negative 70 degrees. My reference angle is super simple. It's whatever the x-axis is, right? So either 360 or 180, whichever one it's closer to, subtracting whatever angle is given to me. So my reference angle, doing a different color here. My reference angle is, if I would have gotten myself, it's what's left over right here that makes me get to 360. Well, it's kind of happens to be the same one as this over here, but if I take 360 and I subtract 270, 290, excuse me, I end up getting 70 degrees. So this that's left over is 70 degrees. It's a positive angle that gets you back to the x-axis. Okay, easy peasy. Now we're gonna do the next one. All right, negative 4 pi over 5. Now you've got some choices. You can leave it like this, or you can convert it into degrees. It's kind of whatever makes your heart happy. I'm just gonna leave it like this to start. We're going to sketch it out now. Okay. Now, I know that over here, 180 is really pi. And I know that 0 is really 2 pi, right? If it helps you out, right, I can change this to be degrees just so I know where I'm putting it, right? So if I wanted to change this into degrees, I would have to multiply by 180 over pi. And I would end up getting negative 144 degrees. Okay, now negative 144. That means I'd have to go down 90, and this gets me to 180, so it's going to be somewhere over here, right? Negative 144 degrees. Okay. Now, coterminal angles means All right, I have to add 360 to it or subtract 360 to it. Well, we're actually working really in radians over here, so I'm either going to add 2 pi or I'm going to subtract 2 pi from it. Okay, so that's what I'm going to do. So I've got negative 4 pi over 5. So the first thing I'm going to do is I'm going to add 2 pi to it. Well, right now I can't add these together, right, because they don't have the same denominator. So I can change this to have a denominator of 5 if I just multiplied this by 5, right? So if I did that, I would end up getting 10 pi over 5, right? That's the same thing as 2 pi. So if I were to add negative 4 pi plus 10 pi over 5, I'm going to end up getting 6 pi over 5. That is one coterminal angle. The other one is when I take this and I subtract 2 pi. Okay, instead of putting minus 2 pi, I'm going to put minus 10 pi over 5, right? Because then the denominators are the same and I can actually do that. Well, if I subtract those two, I end up getting negative 14 pi over 5. All right. Now, my reference angle, okay, reference angle has to get me back to the x-axis. So the reference angle is what's left over here in this little section that gets me to 180. Well, if I do it first with degrees, because I already know I'm at 144 and 180, I can go, okay, if I do 180 minus 144, that should tell me what's left over in degrees. Well, left over in degrees would be 36 degrees. But I'm doing everything in radians. So I'm just going to take that 36 degrees and I'm going to convert it into radians. So in order to do that, I'm going to take that 36, I'm going to multiply it by pi over 180. So I get 36 pi over 180. And then I just reduce it. And I can divide them both by 36. So I get pi over 5 as my reference angle. So you can convert back and forth from degrees to radians, radians to degrees. You just have to make sure that your answer is given in the same form that is given to you. So if I give it to you in degrees, make sure your answers are in degrees. If I give it to you in radians, make sure your answers are in radians. All right, number 14. The terminal side of an angle in standard form passes through the point 6, negative 4. Make a sketch, then find each function value. Okay, so I'm going to start by sketching the point 6, negative 4. So that would be 4, 5, 6 on the x, negative 4 on the y. All right, be right about there. Okay, that's the terminal side of the angle. That means it starts here on the x-axis and it ends over here at that point, and I make myself a right triangle. So I've got the x is 6, the y is a negative 4, and I have to figure out what my unknown side is. That's the r side, right? That's what I'm trying to figure out. It's essentially the same thing. It's my radius of the circle. So just like what I did in the very first problems, I'm going to have to find the unknown side length of a right triangle. So I'm going to use the Pythagorean Theorem. I'm going to end up doing, though, instead of a, b, and c, I'm really using x squared plus y squared equals r squared. So my x value is 6 squared, my y value is negative 4 squared, and I'm trying to figure out what my radius or my hypotenuse is. So 6 squared gives me 36, negative 4 squared gives me 16. If I add those two together, I get 52. And then to get the r by itself, I'm going to square root it. Well, 52 is not a perfect square, but I can break it down to be a perfect square times another number. So I can do 4 times 13 gets me to 52. And I know that 4 is a perfect square. So my r value, my radius, is really 2 radical 13. I already know my x variable, and I already know my y variable, which is fantastic because now I have my 3 different sides of the right triangle. So now I should be able to do my sine, cosine, tangent, cosecant, secant, and cotangent. Now, if you remember from before, sine still means opposite over hypotenuse, okay? And my reference angle would be in the center. So opposite over hypotenuse is really y value, this is the y value, divided by the r value. Cosine is really, so the adjacent over hypotenuse is really the x over the r. And the last one, tangent, is the opposite over adjacent, which is really the y over the x. And that's always going to be the way that it works every time for problems like this. So if you memorize this, you're just as good. Okay, so let's start by doing our trig functions here. Make sure everything's in the screen. Okay, my sine is y divided by r. So that would be, so I'll come do it over here, right where there's a little bit of space. Okay, my y value is -4. My r value is 2 radical 13. Okay, I know I can reduce these, so I'm going to do that first. I know the 2 cancels, and the -4 really becomes -2. And then I move it up, clean it up. So it becomes -2 radical 13 over 13. I've got nothing else to do, so that's my final answer. That's my sine. Cosine is x over r. So that would be 6 over 2 radical 13. Well, I can reduce these. This cancels, this becomes a 3, and then I move it up, clean it up. So it's 3 radical 13 over 13. There's nothing else to reduce, so that's my final answer. Last one, tangent, y over x is -4 over 6. And I can reduce, I can divide them both by 2, so it's -2 over 3. All right, there's my first 3. Now I'm going to do their reciprocals, okay? So if I do the reciprocal, I'm going to go back to the original. I'm going to do, I have a little bit of space next to it. I'm going to do it over here. So the cosecant is really 2 radical 13 over -4. And I know that these can cancel. This becomes a 1, this becomes a 2, and then I'm done. So I've got radical 13 over a -2. Secant, same sort of thing. I've got 2 radical 13 over 6. My 2 and my 6 can be reduced to be a 1 and a 3. So my answer is radical 13 over 3. All right, so I'm just reducing for each one. And then over here, cotangent, I can just flip-flop these. Instead of it being a -2 over 3, it's a -3 over 2. And there is my final answer. So there are the 6 trig functions for a angle that passes through the point 6, -4. So you just have to really be careful when it comes to these types of problems with your radicals, making sure that you don't have a radical at the bottom no matter what. Okay. Now for 15 through 20, we're going to find the exact value for each trig function. And remember that we had 4 steps that we went through, to find the exact values of each trig function. So we sketched a picture. We had to determine what the reference angle was. Then we had to determine what type of special right triangle it was. And the last thing we did was we had to determine if it was going to be positive or if it was going to be negative. Now, I'm going to write at the top of my paper my SOHCAHTOA so I don't forget it. The other thing to remember is when these trig functions are positive. So remember, we think about the mnemonic device, all students take calculus. So all of the trig functions are positive in the first quadrant. The sine and its reciprocal are positive in the second. Tangent and its reciprocal are positive in the third. And then cosine and its reciprocal are positive in the fourth quadrant. So that's something to make sure that we remember as we go through each one of these problems. Okay. First thing we want to make sure is that it's in degrees, because that's easier to draw. So I've got tangent of 135. So the first thing we're going to do is we're going to sketch a picture. Did an orange here. Okay. So I start on the x-axis, my initial side. Terminal side's 135, so that is between 90 and 180. So it's somewhere over here. Doesn't have to be perfect. This is 135 degrees. Okay, next step is to find my reference angle. My reference angle is what is left over to get me to the x-axis. So this would be whatever my reference angle is, right over here. This little kind of section here. In order to find that, I'm just going to take 180 and I'm going to subtract 135. When I do that, I get 45 degrees. So that means right here, my reference angle is making me a 45-degree triangle. So now that's what I'm going to draw. Okay, across my 45s are always a 1, and across from my 90 is always a radical 2. Okay, I know my reference angle's on the inside over here. It's the 45 degrees. And I'm looking at tangent, which means opposite over adjacent. So opposite is 1, adjacent is 1. So it's opposite over adjacent. So it's 1 divided by 1, which just gives me a 1. And then I know I'm in the second quadrant. The only thing positive in the second quadrant is the sine. I'm looking at the tangent, so my answer has to be negative. So my final answer is the tangent of 135 degrees is negative 1. And there I go with the first one. Number 16. Cosecant of 240 degrees. It's in degrees. I'm going to sketch it. I guess I should keep doing it in the same color, huh? Okay. So 90, 180, 270, 360. All right. 240 degrees means I'm right about over here. I'm between 180 and 270, right? So this whole thing is 240 degrees. My reference angle is the piece that gets me back to my x-axis, so it's over here. So I'm going to do, to find my reference angle, I'm going to take the 240 and I'm going to subtract 180, and that's going to tell me what's left over. When I do that, I get 60. So I know my reference angle is a 60 degrees. So I'm going to draw myself my right triangle with my reference angle of 60 degrees. That means the other one must be 30. Across from the 30 is a 1. Across from the 90 is a 2. Across from the 60 is a radical 3. Okay, I am doing cosecant. Cosecant is the reciprocal of the sine. So it's going to be the hypotenuse over the opposite. So my hypotenuse is 2. Opposite of the 60 is radical 3. Now I need to rewrite that because I can't have radical at the bottom, so I move it up, clean it up. It's 2 radical 3 over 3. There's my answer for the cosecant of 240. Last step is to see if it's positive or negative. I am in the third quadrant. The only thing positive in the third quadrant is the tangent and its reciprocal, so my answer is going to be a negative. So my final answer is cosecant of 240 degrees equals a negative 2 radical 3 over 3. Number 17. First thing I'm going to do is I'm going to draw my angle that's given to me. So if I'm doing 120 degrees, that means it's in between my 90 and 180. So it's probably about here. Something like that. Just a quick sketch. Okay. Now I'm going to find my reference angle. So my reference angle is this piece that's left over to get me to the x-axis. So I'm going to end up doing 180 minus 120. When I do that, I get 60 degrees. So I know my reference angle is a 60, and I'm going to draw that picture. And I'm going to mark my 60, it's my reference angle. So across from the 30 is a 1, across from the 90 is a 2, across from the 60 is a radical 3. All right. I'm looking at the sine. Sine means opposite over hypotenuse. So the opposite, sine is opposite over hypotenuse. Okay, opposite is radical 3, hypotenuse is 2. So my answer is radical 3 over 2. I don't have anything to reduce there. Last step is to see if it's positive or negative. So I am in the second quadrant. The only thing positive in the second quadrant is the sine. I'm looking at the sine, so my answer is going to be a positive. So final answer is sine of 120 degrees equals positive radical 3 over 2. You do not need the positive sign there. I'm just putting that so that you can tell as you're going through. All right, number 18. Cosine of 7 pi over 4. Now, this is given to me in radians. I always want to make sure I have it in degrees because it's way easier to sketch. So we're going to change this into degrees, and we're going to do that by multiplying by 180 over pi. My pi's cancel. I end up getting 315 degrees. All right, so now we're going to sketch it. If I start on the x-axis, I know this is 270. So I go all the way to 270. I don't quite get to 360, but I'm probably somewhere about here, right, in this fourth quadrant. This gives me 315 degrees. Okay. My reference angle gets me back to 360, so it's this section in here. So I'm going to do 360 minus 315. And my reference angle is 45 degrees. So I know this is a 45-degree triangle, so now I'm going to draw it out. Okay, 45 is my reference, so I've marked it. Across from the 45s are 1s. Across from the 90 is a radical 2. Cosine means I'm going to do the adjacent over the hypotenuse. The adjacent would be a 1. Hypotenuse would be a radical 2. So it's 1 over radical 2. Remember, I can't have a radical in the denominator, so I move it up, clean it up. So I end up moving it to the top. You don't really need the 1, so I'm just going to leave it as a radical 2 over 2. Last step is I just see if it's positive or negative. So I'm in the fourth quadrant. The only thing positive in the fourth quadrant is the cosine, and I'm doing cosine, so that means my answer is going to be positive. So my final answer is cosine of 7 pi over 4 equals a positive radical 2 over 2. Make sure when you're writing your final answer, you go back to whatever form is given to you. So don't write it as degrees, write it as radians, because that's what I gave it to you as. All right, last two, we're so close. 19. Okay, the secant of 2 pi divided by 3. All right, it's given to me in radians, so the first thing I'm going to do is I'm going to convert it to degrees. I'm going to do that by multiplying by 180 over pi. So I end up getting, divided by 3, so I get 120 degrees. All right, so now we're going to draw that picture. So I start on the x-axis, I go about there. past the 90 towards 180, but not quite there. My reference angle, right, is over here. It's whatever gets me to the 180. So to find my reference angle, I'm going to do 180 minus 120. And my reference angle is 60 degrees. So I know this triangle is a 60-degree triangle. So I'm going to draw that. And I'm going to mark it accordingly. So 1, 2, and a radical 3. All right. Now, secant is the reciprocal of the cosine, so I'm going to end up doing the hypotenuse divided by the adjacent side. So so I'm looking at the 60, right? That's my reference angle. So the hypotenuse is 2, adjacent would be 1. So it's 2 over 1, which is just 2. Last thing I'm going to look at is if it's positive or negative. So I'm in the second quadrant. The only thing positive in there is the secant and its reciprocal, the sine. Whoa, Mr. Masso. The sine and its reciprocal. I'm looking at the secant. That means this is not a positive. This answer has to be negative. So the final answer is secant of 2 pi over 3 is negative 2. Okay, last one like that. Cotangent of pi over 6. So first thing I'm going to do is I'm going to change pi over 6 into degrees. So I multiply by 180 over pi. I end up getting 180 divided by 6, which is just 30 degrees. Okay, so start in the x. I know this is 90. 30 degrees is here, right? Now let's think about this super logically. My reference angle means whatever's left over that gets me back to the x-axis. Well, if I only go up 30 to get back to the x-axis, I just have to go down 30. So my reference angle is still 30 degrees. Now I'm going to draw a triangle. 30 is my reference angle. A little star by it. So across from 30, I'm going to mark, right, just the way we have been. 1, 2, and radical 3. Okay, the only thing that's different now is I'm looking at cotangent. So cotangent is the reciprocal of tangent, so that would be the adjacent over the opposite. Okay, so adjacent to the 30 is radical 3. Opposite would be a 1. So radical 3 divided by 1 is just radical 3. Last thing I'm looking at is if it's positive or negative. I'm in the first quadrant, and if I remember my little mnemonic device, all students take calculus. Every single trig function is positive in the first quadrant, so my answer is going to be a positive answer. So my final answer is that the cotangent of pi over 6 is equal to a positive radical 3. Oh, I guess that was hard to see. All right, last page. Now these last ones I think are pretty simple because it's just asking about which quadrant reference angles lie in, so it should be pretty simple. So we should be able to go through these relatively quickly here. In what quadrant does the angle 7 pi over 3 given in radians lie? So all I'm going to do is take that angle that's given to me in radians. I'm just going to change it into degrees. So 7 pi over 3, to change it, I multiply by 180 over pi. I know that my pi's will cancel, so I do 7 times 180, and then I divide it by 3, and I get 420 degrees. Now, if I draw a sketch of it, I know over here would be 360, right? So I'd have to go all the way around once. That's a full circle, 360. I know to get to the next one, I'd have to add 90 to it. So that means over here would be 450. Well, I'm not quite at 450, right? I'm somewhere in here. So my terminal side would be in quadrant 1. first quadrant. Same thing for the next problem. What quadrant does the angle 5 pi over 4 radians lie? I'm just going to change it into a degree. So I do 5 times 180, and then I divide it by 4. I get 225 degrees. Then I think about it. I know down here's 270, here's 180. So I'm going to start on the x. I'm going to end somewhere in here. That would be quadrant 1, 2, 3. Easy enough. Number 22. What is the negative angle of rotation for an angle with a positive angle of rotation 275 degrees? So I'm going to draw myself a little sketch. I know here's 270, this is 360. So I know my angle would start here on the x, and it would go all the way to just past this 270. This whole big thing is 275 degrees. To find what the negative is, that just means going from the 360 down over here to where that terminal side is. So essentially, I just have to take 275 and subtract 360 from it, and that's going to give me what's left over. So if I do 275 minus 360, I get negative 85 degrees. So this, going clockwise, makes it negative 85 degrees. So it's essentially just what gets you to a full rotation of 360. Same thing for number 23. What's the negative angle of rotation for an angle with a positive angle of rotation 123 degrees? So it's the same sort of thing. I'm going to draw a quick sketch. 270, 360. Okay. So it's past the 90. It's somewhere over here. This is my positive 123 degrees. And I just want to know the negative means I'd start at 360, it would go all the way around the other way. So in order to figure that out, I can just do 123 and I can subtract 360 from it. I end up getting negative 237 degrees. And there's my answer. All right, last few. Find the measure of an angle in degrees in standard position for a reference angle 35 degrees in quadrant 3. So I'm giving you the reference angle. I'm giving you what's left over to get you to the x-axis. I want to know what the rest of the angle is. Okay, so we're going to draw ourselves a sketch. Oops. Okay, now if I'm in quadrant 3, 1, 2, I should mark them right, 1, 2, here's quadrant 3. Okay, if I have a reference angle of 35 degrees, that means it's 35 degrees past 180. Okay, now in standard position, that means I would start here at the 0, or at the x-axis, and I go all the way around to that terminal side. So essentially it's 180 plus this reference angle of 35 degrees. So I'm going to take 180 plus 35, and I get 215 degrees. And that is my angle measure. All right, same sort of thing for number 25. I don't know why there's a 7 there, sorry. Find the measure of an angle in standard position for a reference angle 65 degrees in quadrant 4. Okay, so I'm coming here and do the same thing I just did. Okay, and I'm going to label my quadrants. All right, now, if the reference angle is 65 degrees in quadrant 4, that means, here's my x-axis, I have to go down 65 degrees. Okay, I'm going down 65 degrees. Now, in order for it to be in standard position, that means I'm starting at the x-axis here, and I'm going all the way around to the other side. So essentially, I'm taking a full circle of 360, and I'm taking away the 65-degree reference angle that's given to me. So I'm doing 360 degrees minus 65 degrees is the reference angle. My answer is 295 degrees. So to get from here all the way down over here, it's 295 degrees. And that makes sense if I look at my picture. So that's a really great way and a good reason to always draw a picture. All right, last one. Find the measure of an angle below has a positive angle measure, a negative angle measure, and a measure greater than 360 degrees. Okay, so I've got my X and my Y, and I'm going to mark my degrees. So I know this is 360, 90, 180, and 270. What I'm telling you in the picture is that this reference angle right here is 35 degrees. Okay. So that means to get from this point to this point, it's 35 degrees. My standard position would be starting at the X and going all the way to that terminal side over here, where I have 35 degrees left over. So to figure out just what this angle is right here in blue, I'm going to take 180 degrees and I'm just going to subtract the reference angle from it. Okay. If I do that, I get that this angle in standard position is 145 degrees, which makes sense if I look at my picture, right? 145 plus the 35 gets me to 180 degrees. Great, there is my positive angle measure. To get myself a measure that's greater than 360, I just have to add one revolution to it. So I'm gonna go around 360 degrees, so a full circle, and then I'm going to add that 145 to it. So I'm going to take 360 and add 145. When I do that, I get 505 degrees. Okay, so now we've got it as a positive. We have it as a measure greater than 360. The last one is to find it as a negative angle measure. So a negative means I start over here on the x-axis, but now I go, ooh, that one's not working. I'm going to the left, I'm going clockwise. So I'm going, here's 90, here's another 9, I've got 180, and then I add that 35 to it. So I'm now going 90 plus 35. So essentially, I'm adding, right, the 90 and the 35 together. That would give me my negative. Or what you can do is you can just take the whole 360 and subtract what you have over here as the positive. So you have a couple different choices. So if I subtract 360 or 145 from 360, I get a negative, I'm going to get 215 degrees, but because I'm going to the left, it is a negative 215 degrees. If you want to think about it another way, you can say if I add a negative 90 plus a negative 90 plus a negative 35. You can do it that way as well, right? So you're adding this piece plus this piece plus this piece. Again, you're still going to get negative 215 degrees. And there you've got it. You've got one picture as a positive angle, a negative angle, and a measure greater than 360. So those are all considered coterminal angles. Okay, we are now finished with our study guide. So I would suggest that you go back through, you check, you maybe mark questions that you are having some issues with, and then make sure that you are coming on for our office hours this week so that you are going to be able to check your work with mine and be ready for your assessment that will be given to you later in the week. So I hope that that helped you guys out. Have a grand day, and I will talk to you all very soon.